Hi, welcome to Land of Chemistry. Simple steps to organic chemistry. In this video, we are going to learn the preparation of amines from alkyl halides. First, let's learn Gabriel Phthalimide synthesis. Here we are taking phthalimide, which is prepared from phthalic acid, along with the benzene ring C double bond O, and in another position C double bond O, here NH. This is phthalimide. We are going to react it with KOH, that is alcoholic KOH. What happens during the reaction? The hydrogen from the phthalimide and OH from the potassium hydroxide will leave as H2O. Here we use this alcoholic alkali, that is potassium hydroxide. This potassium will replaces the hydrogen. So we get C double bond O, here C double bond O, here N. Instead of this hydrogen, potassium is attached. This is known as potassium phthalimide. This potassium phthalimide is again treated with methyl chloride. This is methyl chloride. What happens during the reaction? The potassium from the potassium phthalimide and chlorine from the methyl chloride will leave as KCl, that is potassium chloride. This methyl group will replaces the potassium. So we get instead of this potassium, CH3 will be attached. The name of this compound is n-methyl phthalimide. This again is treated with aqueous KOH, that is KOH in presence of water, H2O. Here, 2 potassium hydroxide will take part in this reaction. The bond will get cleaved here. In this 2 potassium hydroxide, OK will get attached to this carboxyl group, and here OK. And this remaining H2 from 2 molecule of KOH, the H2 will get attached to this nitrogen. So we get CH3 NH2, which is known as methylamine, a primary amine. The remaining thing to the benzene ring, that is OK. COOK. Here COOK, which is known as potassium phthalate. Come on, let's summarize the reaction. When phthalimide is reacted with alcoholic solution of KOH, a removal of water molecule takes place and this potassium replaces the imide hydrogen and we get potassium phthalimide, which on further treated with methyl chloride, that is alkyl halide, we get N-methyl phthalimide, which on again treated with aqueous KOH, that is aqueous alkali, we get potassium phthalate and the product methyl amine, which is known as methanamine, a primary amine. Next, we are going to prepare amines from alkyl halides by Hoffmann's ammonolysis reaction. Ammonolysis means addition of ammonia. That is, we are going to add this ammonia to this alkyl halide. Here we are taking methyl bromide as a reactant. We are going to react it with ammonia, that is NH3. For our convenience, I am splitting this ammonia in this way. The reaction takes place on heating. Here, the bromine from methyl bromide and hydrogen from ammonia will leave as HBr. And this amine group will replace as the bromine. So we get methanamine or else methylamine. Here NH2. For our convenience, I am writing this NH2 in this way. I am splitting this. This is a primary amine. This on further reacting with methyl bromide, that is alkyl halide is added again. Here the same thing takes place. The hydrogen and this bromine will leave as HBr. This methyl group will replace as the hydrogen. So we get a secondary amine, that is CH3NHCH3, which is known as N-methyl methanamine. This one again treated with alkyl halide, the same methyl bromide. What happens? The same process. This bromine and this hydrogen will leave as HBr and this methyl group will replace as the hydrogen. So we get a tertiary amine CH3NCH3 CH3, which is known as N, N dimethyl methanamine. This on further treated with methyl bromide, we get a quaternary ammonium bromide, which is a quaternary ammonium salt, that is CH3 NCH3 CH3, here CH3. This nitrogen will carry positive charge and this bromine will carry negative charge. Instead of writing this in this way, we can write this quaternary ammonium bromide in this way also. CH3 4 times N plus Br minus. Come on, let's summarize the reaction. When alkyl halide or benzyl halides are heated with alcoholic ammonia in a sealed tube, a mixture of primary, secondary and tertiary amines and quaternary ammonium salts are obtained. Actually, this is a nucleophilic substitution reaction. The halide ion of alkyl halide, here methyl bromide, is substituted by ammonia group, that is amine group NH2. The product primary amine so formed can also has a tendency to act as a nucleophile, and hence if excess alkyl halide, excess methyl bromide is taken, further nucleophilic substitution takes place, which leads to the formation of quaternary ammonium salt. However, if the process is carried out with excess ammonia, the major product will be primary amine, that is methyl bromide. Here, the reactivity of alkyl halide will be in this way, that is alkyl iodide will be more reactive than alkyl bromide, and alkyl bromide will be more reactive than alkyl chloride. Okay, so the reactivity of alkyl iodide is very higher than the corresponding halides. Now let's learn the preparation of methylamine by reacting methyl chloride with sodium azide. CH3 Cl. This is methyl chloride. We are going to react it with sodium azide, that is NaN3. This is sodium azide. What happens during the reaction? The chlorine from methyl chloride and sodium from sodium azide will leave as sodium chloride, that is NaCl is left. This N3 will get attached to this methyl group. So we get CH3N3, which is known as methyl azide, which on further reduction, now we are going to reduce this methyl azide in the presence of reducing agent lithium aluminum hydrogen. Here 2 hydrogen will take part in this reaction. 2 hydrogen will get attached to this nitrogen and the 2 nitrogen will get eliminated as a nitrogen molecule, and we get CH3NH2, which is known as methylamine or methanamine. Come on, let's summarize the reaction. When alkyl halide is reacted with sodium azide and followed by a reduction with lithium aluminum hydride, we get methylamine as the product or methanamine. Now we are going to prepare aniline from chlorobenzene. Let's write the structure of chlorobenzene. C6H5Cl. This is chlorobenzene. We are going to react it with ammonia, that is NH3. For our convenience, I am writing this ammonia in this way. The reaction takes place at the temperature of 200 degrees Celsius. The catalyst we use is Cu2O. What happens during the reaction? The chlorine from the chlorobenzene and the hydrogen from the ammonia will leave as HCl, and this amine group will replaces the chlorine. So we get aminobenzene, which is also known as aniline. Let's summarize the reaction. When chlorobenzene is reacted with ammonia at the temperature of 200 degrees Celsius in presence of Cu2O, we get aniline as the product with the elimination of HCl. Thank you.